Okay, I'm beginning. Yeah. So, good morning, everybody. And unfortunately, we are starting with this topic. But in fact, in the morning, I was speaking to Jimmy. Yesterday evening, also I spoke to him. So, generally, this topic continues. This is going to be only the foundation, a basic of it. But if possible, we would like to invite a guest speaker to give the on-site or first-hand experience about this subject. Having said that, today there is a little limitation. You might have a lag because I'm operating from my mobile, this internet. My Wi-Fi is not working. So please bear, and if there are some issues, I don't know how you will conduct. I'll take a pause in the middle and go back to the screen where I'm able to see people's hands or chat box. When I'm giving this presentation, I'm not able to see that. So today I'll take more number of pauses to come back to understand whether we are at the same pace. Yeah. Else you can unmute yourself and just point out that I'm disconnected or something, or just an indication. I don't know how that will work. Okay. Uh, anyway, let's begin. So, pre-stressed concrete. Okay. Uh, why pre-stressed concrete? Why is it that there is an echo now? Somebody is on unmute or something. Yes, Sandhya, can you unmute yourself? Yeah. Okay. So why do we use pre-stressed concrete? What are its advantages? What are the, in fact, properties or shortcomings of regular concrete within RCC? Okay. Uh, Number one is, when we have always looked at, though in spite of the fact that we want to see concrete as, or reinforced concrete as a unified monolithic structure, we conceptually in our minds, we are always thinking about concrete separately as well as steel separately. Steel we associate largely with tension stresses, and concrete we associate with compressive stresses, right? Uh, it is also important that we have a very good bond strength between concrete and steel in reinforced concrete, because it depends on the how the concrete and steel is going to interact together to give the mechanical strength of the overall structure. Now, when you do that, the steel is already laid, and once the steel is laid, there is over a period of time when the material fatigue sets in. Okay, when the material fatigue sets in, what happens is concrete will, because it is under constant tension, the steel which is under constant tension, it might experience fatigue, and there is a certain tendency of the concrete also, or the steel, to release or to expand, stretch in its along its length, resulting in micro cracks in the concrete. Now, when micro cracks initially, all the concrete, whether it is no concrete is not susceptible to micro cracks. Every concrete, every brick, there will be micro cracks. So when these cracks happen in concrete, what happens is there is the water ingress. Because of the water ingress, there is oxidation and deterioration of steel. Because of the deterioration of steel, there is further loss of strength of steel, and there is eventual failure. Okay. So now, how do you prevent the shrinkage cracks? We have seen stirrup reinforcements and all those things, but at a very micro level, how do you prevent shrinkage cracks? How do you optimize the concrete, or how do you utilize the strength of the concrete to the optimum? That is something by which we are beginning with this chapter with. So what are the examples of pre-stressed concrete? I'm giving you three examples. One is the stack of books which is organized vertically on a shelf. and you want to remove the whole books together. So what are you going to do? You are not going to you are going to apply pressure on the both the ends. So you are going to use your palm and apply pressure at both the ends, and you are going to remove the stack of books. Now essentially what you are doing is you are applying pressure horizontally perpendicular to the direction of gravity. Okay. Now that is something that what you are building is you are building a stress within the interfaces of the books, and it is you are introducing the pre-stressing. Okay, before you lift, you are able to lift, you are introducing pre-stressing within this stack of books. Yeah. Similarly, in a bundle of sticks, the bundle of sticks, you are not touching the in between portion of the sticks, you are touching the peripheral bundle of sticks. So in doing that, you are able to introduce stresses on the in the interfaces of all the sticks, and you are able to lift the bundle. Similarly, in a barrel of wine or all these oils, there was a ring introduced at the bottom and as well as at the top. uh, am I able to? The cursor is not visible, right? Yeah,
No,
I'll
it's
do
visible.
this.
Visible. Cursor is also visible. Cursor is visible.
I'm not able to see my cursor.
Yeah, it's there.
Strange, I'm not able to see it. Anyway,
It's there at
so
the haystack.
at the haystack,
Yeah.
I'm not able to see it.
Okay.
It's not moving. Anyway, so I'll use this. Now, in this, your this metal rings are introducing a stress within the wood. If this metal ring was not there, and if the wood were just placed, the wooden planks were just placed next to each other, when the oil or when the wine is filled in, because of the water pressure, these joints will open up. Okay. Now this metal rings are tied, they are pre-stressed. Okay. And when the actual stresses come about, they will they will be able to hold the liquid in firmly. Yeah. Now going to this, what is the difference between reinforced concrete and pre-stressed concrete? So this is a sketch or diagram, and it also we'll be talking about uh, what pre-stress or post-tension this concrete is. Now, without the reinforcement, you have a tendency to get the crack in the middle of the beam. The one of the options is you introduce reinforcement in the middle. This is very schematic. It's just reinforced. But when the rod is pulled on the other side, on either side, then then you are able to make the concrete very strong. We'll come to how we are able to make it stronger in the next slides. But this is just a schematic diagram which will be able to explain what we are meaning. Okay. Fundamentally, if you look at this, the figure on the left hand side, this is a regular reinforcement. The stress is, it is important to connect the top chord as well as the bottom chord. Okay, we know that we have seen the eye section, the connectivity between the flange of the eye section through the web, the top flange and the bottom flange, and through the web. Similarly, in this reinforcement also, it is the top chord and the bottom chord and the connection in between. This is important for you to get the overall kind of a member operational within the as a structural member. Now, in pre-stressed concrete, I don't need actually a designed reinforcement at the top. I don't need a designed reinforcement cage. All I need is this fundamental, these steel tendons. Okay, tendons are nothing but they are the cables, either single rod rods, or they are bundled cables in steel, high strength steel, and when the tendons are pulled on either side, and there is a pressure, there is a pressure applied from both the sides, then you are able to introduce a tension within the concrete. Now, what made this possible? Why was it not done earlier? This couldn't have been possible because this depends on very high strength concrete, uh, 40, uh, uh, 40 m and above. Now, this concrete, it is like you will easily understand that you are applying pressure from both ends. Now, to be able to withstand that pressure, the concrete itself should not crumble. To prevent the concrete from coupling, if you are having M20 or M15 or M10 grade concrete, then these kind of pressures will easily crumble the concrete. The amount of pressure that you are applying in either post tensioning or pre tensioning is quite intensive, which is it will be to the tune, it will be as much as the pressure which is going to come vertically down through the gravity. Now, because of which you need a high strength concrete. Uh, Apart from that, you have high performance. Now, these are the various types of concretes, but I'm focusing only on high strength, high performance, and micro reinforced concrete. These are the ones which have the possibility of being used in pre-stressed concrete. Now, high performance concrete, what is the difference between high performance concrete and high strength concrete? High strength is talking only about the strength of concrete, whereas the performance in terms of its longevity, in terms of its behavior, in terms of its shrinkage cracks, in terms of its ability for penetration of moisture, all of that, the performance expectancy, permeability, density, ease of placement, all other factors, that is high performance concrete. So most of these advanced technologies will use a combination of high strength, high performance, and more recently there is these high-tech concretes which have come about, which is micro reinforced concrete. Now, micro reinforcement, we all know that concrete has very, again it is pointing to the same issue of the micro cracks. If you want to prevent the micro cracks, what are you going to use? You have the possibility of also using microfibers of steel, fiberglass, or plastic fibers that can alter the properties of the concrete. Yeah. So now, what is pre-stressed concrete? Pre-stressed concrete is structural material. It is like just like RCC we consider as one unit material. Pre-stressed concrete is also considered as a unit material together with concrete as well as the tendons. Okay. That allows for pre predetermined engineering stress to be placed in members to counteract the stresses that occur when they are subject to loading. It combines the high strength compressive properties of concrete and high tensile strength of steel. So last sentence which talks about high compressive strength of concrete, M40 and above, and high tension strength of steel, which is high yield steel. Both are important, and the evolution or development in both these materials independently have been able to facilitate the pre-stressed concrete construction. Yeah. So on the right, you are seeing a diagram where you have unstressed beam. When it is loaded, and there is a downward kind of a deflection, right? So this downward deflection is uh, when you have a tendon stressed in both the direction. When they are stressed in opposite direction, there is also a simultaneous pressure applied at the bottom portion so that they are held together. Now, these tendons, when they are stressed and they are released, so what happens is there are two methods we'll come to in some time. Have I lost you guys? Are you able to? I am connected, right?
Yeah, clear, clear. You're clear.
Okay.
Fine. All going
Okay.
well.
Okay. Okay. So when you have tendons stressed, we'll come to post tension as well as pre tension. So a stress can be introduced. This stress pre-stress factor can be introduced in two different ways. We'll come to a little later. But what it does is this amount of stress being incidental on the lower half is going to initially have a tendency of the beam to be deflecting on the upper side. Okay, this deflection, because of the high strength concrete, and this is also coming because there is a gravitational load. Obviously this is not going to fail, because this is carefully modulated so that it just is able to take care of its own self load. When the actual load applies, this beam is again going to flatten out. Okay, so conceptually it's going to flatten out. Yeah, so basically the pre-stressing of the bottom chord, how we do the pre-stressing of the bottom chord, which in effect prepares the concrete and pre-stresses the concrete to be able to take the load from the top. That fundamentally is pre-stress concrete. So there are two types of pre-stressing: pre-tensioning and post-tensioning. What is pre-tensioning? Now, if you look at the diagram on the right, okay, sorry, the figure on the right, you have these concrete members. There is a cast which is made. Okay, you can very well see that the profile need not be rectangular because it is in the it is in the yard. So these casts, these molds are used repeatedly. So one mold can be used n number of times. So if it is a metal mold, it will last for a longer time, or it can be concrete mold. So which means that this pre-tensioning involves a method by which you modular the more number of units you are able to extract out of the mold, the more economical it will be. So when you are expending on high amount of steel, high strength concrete, high strength steel, as well as these customized mold, then what is the advantage? Because everything seems to be expensive and the state of it. So what is the advantage? Whether there is an economical advantage. So when you do that, the economical advantage in effect is drawn from how carefully this is modulated. For example, the same length of the beam, if it was a regular beam, it would have been at least 1.5 times this deep. So the amount of concrete which would have gone, of course, of the lower grade, but amount of concrete which would have been gone would be much more. The amount of steel which would have gone would have been much more. So when you are using these high strength steel and concrete, you have to be careful of optimizing the whole purpose is to reduce the amount of material that you are using in your construction by making, and that's how you're making the construction and the whole design lean. Okay, so the whole effort should be towards making the design lean, and towards making the design lean, you got to be very careful about what is the shape. So over here the designers have reduced where the stresses are not required. So they have narrowed the beam in the middle, and they have broadened it at the end. Okay, now this end shows that the steel is already in tension. Okay, now this steel is pulled, they are in tension, the concrete is poured. Okay, and this has a very good bond strength with the concrete. Okay, they are serrated just like regular steel. They are serrated, they have very good bond strength with the concrete. So when the concrete gets set, what this tensioning, this jacks, they are going to be removed. So what happens is the steel tends to go back to its original length. So because the pre-stress, they were stretched and they were pulled apart. They will try, because of the elastic property of the steel, they will try to go back to their original position. When they are trying to go back to the original position, and because of the bond strength between steel and concrete, they will start introducing the stresses which are required for the pre-stress concrete. So this is one method. Okay. Uh, Now, if you want to read, we can read a little so that the figures and the numbers are in place. So pre-tensioning involves the stressing of wires or cables by anchoring them at the end of a metal frame, which may be up to 120 meters in length. So which means that if I want to make 6 meters this in a single go, I can can have 120 meters divided by 60. So 20 units can be cast in one go. Okay. So obviously it is not about single beam. So over here in this image also, this beam is separate, the other. So it is in series. So up to 120 meters can be cast in one go. Okay. Hydraulic jacks stress, but that doesn't mean that this will be used as 120 meters. They are cut in the middle. So the steel is also cut. The steel at the ends are also cut. So after this whole process is done, these ends are cut. Okay, and the steel is allowed to introduce the stress in the middle. Hydraulic jacks stress the wire as required, often adding 10% to accommodate creep and other pre-stress losses that may be incurred. Side molds are then fixed and concrete placed around the tension wires. The concrete hardens and shrinks, gripping the steel along its length, transferring the tension from the jacks to exert a compressive force in the concrete. Once the concrete has reached the desired strength, the tensioned wires are released from the jacks. A typical concrete strength of 28 newtons per millimeter square can be achieved by 24-hour steam curing as well as using additives. To create shorter members, dividing plates can be placed at any points along the member, which when removed permit the cutting uh, of the wires. So these are this are the positions of the dividing plates. Yeah. Coming to post tensioning, this is instead of tensioning before the concrete is poured, this method involves tensioning after the concrete is poured and everything is done. So what does it mean? It is This is a reverse method to pre-tensioning, whereby the concrete member is cast and the pre-stressing occurs after the concrete is hardened. This method is often used where stressing is to be carried out on site or after casting an in situ component, or where a series of precast concrete units are to be joined together to form the required member. Now, this you will often see in across all the metros, this method being used. So next time you are passing by the metro, wherever the ends are not completed, you will notice that there are these brackets which have extensions where people can stand and they can do the post tensioning. So metro construction uses both pre-stressing methods also. So inbuilt the individual units are pre-stressed. So optimization of concrete is done, and even on the side there is a post tensioning which is done in many of the members, so that you have higher strength which are achieved, and they can be adjusted as the over a period of time. With age, you need a slight adjustment in the tensioning also, so those adjustments can also be done. Okay. Now these wires, they can be multi-strand system or they can be rod system. Okay, so for now these cables, strand systems, they are in a sleeve, so there is no bonding between these cables and the concrete. Okay, all the stress, the pre-stress it at the end. So unlike in the pre-tensioning, what was happening was the the concrete was uniformly stressed across its length. Okay, so the stress was created, the pre-stress was created across the length of the concrete. Whereas in this, the maximum stresses are going to be at the ends where the anchorages are, and as it goes towards the middle, the stress is going to be lesser and lesser. Okay, so So what are the anchorages and the tensioning systems? So you have anchorages which are like this. So even within the concrete, there is a lot of detailing which goes into making of this. At the termination, this concrete should not fail. So there is some care which is taken over there. The concrete will have, because it is under stress, it will have a tendency to deteriorate faster. So the amount of the grouting which is done and all that needs to be carefully done. So overall, there is the termination requires very special kind of a treatment that when we are discussing with Satish Jain, we'll come to the details. So you should ask him whenever, if it is possible, first of all. how the details work out, these kind of micro kind of understanding of pre-stressed concrete and the detailing of the concrete, I think person from the field would be the best equipped to explain that. Uh, yeah. So so anchorage. So there are many types of post-tensioning system. There is a Fresnel system which enables the stressing strands to be tensioned simultaneously using center hole tensioning jacks anchored by tapered jaw. Uh, this method is suitable for elements up to 50 meters in length. The Micalloy system, on the other hand, involves solid bars, usually of diameter of 25 mm to 75 mm. That's almost 3 inches. That's quite so. The bar is anchored at each end by special nuts, which bears against an end plate to distribute the load. Yeah. So end plate also is critical. Yeah. Then we come to what are the advantages and disadvantages. Okay. Just a second. Just give me a minute. I'm just sorry. So there was this. I had to reconnect the phone. Okay. Can you hear me now?
Yeah, clear, clear.
Okay. So advantages and disadvantages. The advantages of pre-stressed concrete include inherent compressive strength of concrete used to its fullest, which means that now we are no longer like earlier, because the concrete was M25 or M10 or M20, and the systems were this. So there was no way of utilizing M40, M80, or M120 grade concrete. Okay, because it simply didn't justify. Because at the end of it, the amount of concrete that if you're going to use the same amount of concrete as you're using in your regular beam and construction, why should we spend for more expensive concrete? So that was the general thought process. So in fact, this system, it's quite strange that this system was pre-stressed concrete system was first invented in 1886, and it took almost 50 years for the industry to take up this as a relevant construction method, simply because it was too ahead of its time. Okay, and only when the World War II, after the World War II, the construction was required at a much larger scale, and you required to make very lean elements. That is the time when people started using pre-stressed concrete. This now coming back to this inherent strength of the concrete to the fullest. Till that point of time, the concrete, the focus was more on the steel and the reinforcement and the rebars, the serrations and the bond strength and all that. Only when we had this idea that stress can be applied from both the sides instead of the steel taking the stress at the bottom as the bottom chord and the top chord. That is the time when we started looking at utilizing very high strength of the concrete to its fullest. Okay, so now we use very high strength concrete M80 and above for particularly for skyscrapers, and they are pre-stressed. Uh, so pre-stressing is not just about beams and slabs. They are used for playing fields like your basketball courts. They are used for high-rise buildings, tall skyscrapers, where the vertical cantilever, the column members are pre-stressed, so that the concrete, the columns dimensions are lesser, and you are able to use high-strength concrete. Yeah. The special alloy steel used to form pre-stressing tendons are used to their fullest. So similarly, just like your very high-end concrete, high-end steel was also not being used to the fullest for the same reason. Now with this, you are able to apply stress to the steel, and you are able to use the tendons, the pre-stress members as members to the fullest. So just by reducing the amount of steel that you are using. Tension cracks are eliminated, reducing the risk of steel components corrosion. Yeah, this I have already explained. In fact, I started the topic with this. So tension cracks are a constant menace for your regular structural members, and if you are able to eliminate the tension cracks in the concrete, then the risk of steel components corroding is lesser. Shear stresses are reduced. Uh, because you have already these cables which are very high strength, and this the shear stresses are reduced. Anyway, I think there is a problem with that also was in file. Anyway, I'll use the reference of this. Yeah. So for any given span and loading condition, a reduction in weight can be achieved from using a component with a smaller cross section. Uh, A composite member can be formed by joining individual precast concrete units together. What are the disadvantages? There is a high degree of workmanship, and the control required is also very high. Special alloys of steels are more expensive than traditional steels used in reinforced concrete. Expensive equipment is needed, and therefore complex safety requirements are required. So what does that mean? That pre-stressed concrete, you require very elaborate and very advanced kind of a setup, yeah, amongst the contractors. So your regular contractors will not be able to execute these kind of jobs. You need specialized contractors having the specialized equipments. Uh, the steel as well as concrete also ends up being expensive, and the workmanship required is also very high. Yeah. So with that, we are uh, we are done. That was the last slide actually. Thank God. Okay. So I'll check. I'll figure out what went wrong, but that opens if there are any questions. See, the idea of introducing this was that you at least have introduction to the fundamentals. I am told that you did have a fundamental introduction in the third year. So based on that, if there are some questions between today and tomorrow, so that you are prepared, your fundamental understanding of precess concrete is clear, And when we call guest speakers, we have
No, I think couple of things were important.
yeah.
One is that I'm glad you took it because I would end up repeating myself to what I had taken in the third year. So, but naturally, opened up many new, you brought in the four many new concepts which I couldn't cover in the third year. The other very important thing is in thesis, there is a there are people who design by default saying that they have RCC structure, though the numbers are decreasing by the day, as we see that people are now being more specific, material specific, and that is lending character to the building to a very large extent. But yet there are large number of students who draw plans out, yeah, and and their default material is RCC, and they are usually questioned on two fronts. Either is why is the grid 6 by 6, so they are stuck with the third year understanding that a normal slab beam requirement is 6 by 6. So usually they are questioned that why are the columns so close apart for an institutional building of this order, or they are so far apart and someone asks them what kind of technology use and they have no idea. On either front, when students use RCC technology by default in their projects, they are unable to justify why they have chosen RCC and what is the technology they are adopting, especially for institutional buildings, large projects where post stressing can play a very important role in it.
So yeah, so I hope we have been able to at least there is a clarity with the subject fundamentally. The details, of course, there are a lot of details and a lot of questions, but I don't want to get to that details without getting an assurance that you have understood or conceptually the things are clear. Because on the internet I went through the internet and there are many videos explaining what pre-stressed concrete is and how is it done on the site and all that. So that is available. What was not available was what I shared just now. Actually, means a lot of our understanding also is from the Barry as well as speaking to Satish Jain and others. So over a period of time, we have acquired certain understanding of what is important to understand conceptually. So, and many a times, at least in the initial years, even I was finding it difficult to teach this topic and fundamentally difference between reinforcement and post tensioning, because many a times I used to come across this question as to, does that mean that we don't require reinforcement? Does that mean that the cables are cables are replacing the reinforcement? So those kind of questions, if there are any, please come up with it. Let's discuss all those questions and then make this conversation richer. I hope people are listening and there's no response.
They are
Hi, good morning.
usually listening, but this is a class that doesn't respond.
I had a question which I've
Yeah.
put on the chat box, but I don't think it's visible. So, I wanted to ask that does pre-stressed concrete lose its strength faster than conventional RCC method?
No. In fact, the fatigue in concrete, the regular concrete will be much faster as compared to pre-stressed concrete. So, because the tension and it is all, it depends on the design of the member itself. If the design is not optimal, if it is not able, for example, in let's say these large span bridges, okay, they are each member is minimum 50 meters apart. So the supports are, and even the spanning members of 15 meters, 30 meters to 50 meters. So in those kind of sections, if you have looked at the metro sections, how they are laid and all, uh, now there is a slight camber towards the top. There is a slight curvature towards the top. Okay, that is essentially it is a component of pre-stressing. Okay, so when this camber is done, it is anticipated that there will be a certain load which will come on the top, and when that load comes, it will flatten out. So which means that if it was flat in the first place, and then the load came, and the curvature was in the downward direction, then there will be a tension crack. Okay, but if the curvature is upward before the load is done, and then the load happens and it flattens out, then there won't be any tension crack. So this is a fundamental difference. So if there are no tension cracks, if you are taking care, the design takes care that the tension cracks do not occur, and the loads are balanced by pre-stressing, then since the cracks won't occur, the moisture ingress into the concrete will not happen, and the steel will not it will not corrode. Having said that, there is a tendency of the, particularly in the post tension as well as pre-tensioned this, when the strength of the steel gets over a period of time with the material fatigue and all, when that gets compromised, there will be certain kind of relaxation of the steel and all. But because it is a high yields, the steel is also of a very high grade, its resistance to corrosion will be much more. Besides, in the post-tensioning ones, you also have the possibility of readjusting the stress within the concrete. So there is a periodical inspection in post-tension one. In periodical inspection, if it is realized that the tension has gone below a certain kind of a limit, then they are tightened, they are stressed again. Okay, so pre-stressing, post-tensioning allows you to do that. So again, going back to your question, it is in fact pre-stressing in the long run will perform better as compared to your regular concrete.
Okay, understood. Thank you.
Any other? I somehow, though it's a hardcore engineering subject, but because of this field, there are a lot. It opens out a lot of many possibilities for architects to revisualize their designs. So it allows a lot of leanness to the design. It allows a lot of flat slab construction to happen. So the beams are kept to the minimum. Beam can be hidden. So you can design a full floor plate without the beam. So presently, whatever you are seeing as flat slabs, invariably most of the time they will be using pre-stressed concrete. Okay, simply because the traditional conventional flat slab system was found to be very poor in its shear strength. There was a lot of failure of because of the shear. Now, with pre-stressed concrete construction, with these technologies, you are able to eliminate the shear. In shear also, these perform very well. So you are able to eliminate that fear which was earlier there with the traditional flat slab construction. So that is one. Second, between asphalt or a regular concrete, for tarmac or for playing fields like basketball courts and all. So it's not that a pre-stressed concrete is now going to have cracks. It will concrete, if it is concrete and if it is this, it will have cracks. But the difference is going to be that in asphalt or other, the cracks are going to grow wider and wider. Whereas pre-stressed concrete, the cracks will not go; they will be arrested. They will be arrested by the steel, the tendons itself. So the tendons perform differently. Whereas a steel regular reinforcement works in the gravitational this tendons work. They hold together in the perpendicular direction. No other questions?
Hello, Vikram.
Yeah.
Uh,
Swami.
yeah. So in post-tensioning, because the stress is not divided equally across the entire length, is the steel reinforcement designed in a certain way to take care of the stress at the ends?
Yes, there will be a lot of hoops or rings closely spaced at the ends. There will be a stress plate which will transfer the load so that the concrete at the end doesn't get affected. So there is a lot of detailing which happens at the ends. So it's not that the concrete, the stress is not evenly distributed. So it is just that the bolting system, the tightening anchorage system, at that junction, the concrete is little more vulnerable to the impact, not impact, the tightening, the mechanical stress at that. But once the stress goes beyond that interface, then it is uniformly distributed across the length. It is only the ends which are problems where you require a high amount of steel. Yeah, does that answer, Swami?
Yes, Vikram. Yes, thank you.
Vikram, I had one more question.
Yeah.
In the pre-stressed concrete, when the steel tendons are cut right at the two ends,
Yeah. Yeah.
are they cut at the same time, or like, because from the diagram which you showed, it seems that it will work perfectly when both of them are cut at the same time at the two ends.
Same time, or it is like one by one also. If it gets cut, it doesn't matter, no, because the steel, anyway the concrete is set, so it is not going to be as if it is going to snap like a rubber band. If that is what, if you're visualizing it that way, it won't happen that way. So you can cut it one after the other also. But yes, when you are cutting, you have to be extremely careful. You have to release the tension first and then cut the cables.
All right, understood. Thank you.
Yeah. um, I hope when you are designing your uh, structures, large span structures and all, you're able to utilize these. I think with pre-stressed concrete, we have covered most of concrete technologies in the last 5 years, right from basic slab and beam construction to advanced slabs like flat slabs or rib slabs and waffle slabs and diagrades. And even in beams, we have looked at earthquake resistance. We have looked at the relationship between tension and compression in structures. And then finally, this is one technology which we are, we have covered most of the concrete construction. So I hope you are able to utilize at least where you require concrete construction. We have covered all that is required. Yeah.
Vikram, the attendance, and I need to send if you mail me the attendance of today and last Thursday, then I can send it to the college for compilation.
Okay. Okay. I'll stop recording now.
Yeah, yeah.